Hi everybody, Steven here. This is part 4 of our vSphere performance series. In this episode, we're going to take a look at memory. We're going to talk about stuff like VMkernel swapping. We're going to talk about ballooning, transparent page sharing. If you don't know any of that stuff, stick around. We're going to cover it. See you in a bit. Hi everyone, thanks for sticking around. So in this episode, we're going to take a look at memory. We're going to talk about various technologies like ballooning and swapping and compression and all that kind of stuff, right? So this video will have a lecture component so everybody understands the terminologies. We'll look at what the counters we have to watch for. Then I got a bit of a demo I want to show you at the towards the end. Now, I like to point this out, usually right in the beginning. Please support the channel. If this is stuff that you kind of like, please support the channel by subscribing. It's free. Just click on that subscribe link. Also, if there's some videos that you like and you want to share it with your IT coworkers, please share the links. That also helps out the YouTube analytics. Another way to also support the channel is with super thanks. Again, totally up to you. But anyways, that's it. And for those of you, by the way, that have already subscribed to the channel, two thumbs up to you. Thanks for supporting it. Let's get started. Okay, let's jump right into this. So what we're going to take a look at, we're going to talk about this thing called the ballooning, memory ballooning. We'll talk about compression. We'll talk about swapping and transparent page sharing. And then we'll talk about this thing called min free percentage. Well, okay. Anyways, that's basically the amount of minimum memory free your host should have. I'll talk about that. I got a couple slides mentioning it. All right, so the first thing I want to point out before we jump into all this stuff is memory overhead. Nothing's free. When you create a virtual machine, there's a cost to that. Well, a cost in disk space, right? Because a VM is a bunch of files, so right off the bat, you're consuming disk space. But there's also a cost when you go to turn on that VM. The more virtual hardware you give a VM, like the more memory, the more virtual CPUs, the more disk controllers, CD-ROMs, any virtual hardware, there's a cost to it, and that's in memory, okay? And that's what we call memory overhead. So in this example, we see we got a VM that's got about 1 gig of memory and 2 virtual CPUs. That'll take up roughly about 30 megs of memory. Whereas this VM over here on the right has 16 gigs of memory, 4 virtual processors, would take approximately, let's say, 150 megs of overhead. This overhead memory runs in real memory. That means if I go to power on this VM on the right, if I don't have 150 megs of free memory, the VM won't power on, okay? So you gotta make, so be aware of that. Don't be wasteful when you're creating VMs. It's not really a whole lot. 150 megs compared to gigabytes is really just a drop in the bucket, but something you have to be aware of. So when you're creating or planning for your environment, and I'm going to have 100 VMs running on this host, and each of them only going to have 4 gigs of memory or 40 gigs of memory, you got to keep in the back of your mind the memory overhead also. You have to add that into your equations. So I'd like to point that out. All right, ballooning. What is ballooning? First of all, ballooning is a tool that's installed with VMware tools. So it's a driver that's installed with VMware tools. And ballooning is a method for us to claim memory back from a VM. So, for an example, let's say I got a host that has 128 gigs of memory. Great. I now create 4 VMs. And I'm going to give each of those VMs 50 gigs of RAM. I can do that. I can overcommit my memory. No problems. Now, at this point, something's got to give, right? If all of these VMs need access to memory, well, that can't really happen because you got 200 gigs allocated and you only got 128. So there's got to be mechanisms in there like paging and swapping to help us out. So ballooning is one of those tools. Now, in this example I'm showing in this picture, here's my VM, and you see I've got the ballooning driver. It's very small. It means it's deflated. And then at this point in the middle, you'll see, let's say we got contention for memory. Now, all of a sudden, everybody needs memory, and this VM's the one that's losing. This guy's losing the battle, okay? So how this works, if you look at your operating system, let's say you've got Windows or Linux, In Windows, we'll use Windows as an example. Most people are familiar with that, but Linux has a swap file or swap partition or swap file. Now, your operating system will have all these applications that are running, the processes that are running, and they're consuming memory. Now, what happens if you have too many applications running and not enough memory there? Well, you'll end up, your operating system will take the low priority processes or applications and take their contents of memory and put it to its page file or swap partition or whatever. So your operating system's doing that, okay? This is how you're able to overcommit memory on, like in Windows, okay? So what we're doing in this example, and this is kind of a really neat way that VMware came up, it says, okay, I've got this ballooning driver, and it can claim up to 65% of the VM's memory. So here's my VM here, okay? This VM here is before it starts to lose the battle for memory. Let's say it's got 100 gigs of memory, then it can consume up to 650 megs of memory, okay? Sorry, 665 gigs, 65% of 100 gig, right? So what this is doing is it's basically saying, we can't just go in and grab the memory from the VM. Sorry, we need it for somebody else. We're going to grab the memory. The operating system wouldn't really like that too much. Remember, let's say this VM has 50 gigs of RAM. I can't just go in and say, I'm going to rip away 20 gigs or 30 gigs. I can't just do that. The operating system would blue screen or panic or whatever, right? So what we do is we inflate the ballooning driver, and it's a high priority process. So within the operating system, your operating system sees this process, very high priority, and it says, I need access to memory. So what does your operating system do inside this VM? It says, oh, I've got this whatever VMM control that needs memory. I need to take my low priority applications and put it to my page file or swap partition. And that's what this is. This is your page file, or swap partition. That's what this is representing here. So the operating system saying, I need to swap it to my page file. So the operating system's making the decision what application's going to suffer at this point. So this is a way for your ESXi host to trick this VM to saying, you don't really, yeah, you have 50 gigs, but technically you can only use, let's say, whatever, 30% of that, okay? Or to be exact, 35% of it. So, and then let's say at this point, you turned off some VMs, so there's no more contention for memory. Well, the ballooning driver would deflate and say, okay, I don't need that anymore. And your operating system can pull those pages out of that swap partition or page file or whatever, depending on your operating system, and start using it. So this is a very polite way of your host saying, hey, VM, I'm sorry, you're losing the battle for memory. You make the decision on what application inside you is going to suffer, but I need to claim some memory for some other VM. So this is a good thing, okay? Oh, one other thing too. The goal of the ballooning is to make the guest operating system aware of the low memory status of the host, so the guest operating system can free up its memory. You can have an operating system that loads up different applications and they close or whatever, or you minimize them, and they still have those pages in memory that's sitting there. They haven't been, well, lack of a better term, flushed out. This is kind of a method used to say, hey, operating system, flush out your memory that you don't need, okay? So that's kind of cool. Let's talk about VMkernel swapping now. So each virtual machine gets a swap file. This swap file is created when you turn on the VM. It's deleted when you turn it off. Okay? How big is a swap file? The swap file is equal to the amount of memory you gave your VM. So if you give a VM 16 gigs of memory, when you turn on that VM, there'll be a swap file 16 gigs in size. Technically speaking, it's equal to the size of memory you gave your VM minus any memory reservation. So if I give a VM 16 gigs of RAM and I give it a memory reservation of, let's say, 10 gig, when I turn on that VM, that swap file will be 16 minus 10, 6 gig in size. Okay? So this I look at as referred to swapping in the blind. So here's an example. I've got a virtual machine here. This is representing the memory. This virtual machine has, let's say, a gig of memory. The ballooning driver can take 65% of that, so that would be 650 megs. That's ballooning. So that's the polite way of doing things, okay? So the operating system would put it to its little page file, swap file, whatever type of operating system you have. So what's left over? What's left over here is now, let's say that, a gig that's, let's say, 1,000 meg. So that would be 350 meg is left over. Now, let's say this host is really constrained for memory. And it says, hey, VM, this VM here is losing the battle. So the ballooning driver kicks in and it takes its max of 650 megs. So VMkernel says, thank you very much for that 650. But guess what? I need more than that from you, right? So ballooning can't take any more unless you set it to 75, which most people don't do. But anyways, so at this point, your VMkernel will say, you know what? There's 350 megs available. I'm going to start taking that and putting it to that VMkernel swap file for that VM. Okay? That is swapping in the blind. It doesn't know what the contents of those pages are. It doesn't care what application within the VM's using that. It's taking those contents and dropping it to your swap file, the VMkernel swap file. So this is a bad thing that's going to happen. So ballooning is not a good idea. There's one. And then when ballooning can't satisfy things, then at that point we're going to do VMkernel swapping. Now let me ask you this, or not ask, but let me point this out to you. Let's say, and there's some people out there that do not install VMware tools inside their VMs. Whatever, okay? So if you don't install VMware tools, you don't get this ballooning driver, the VM control. You don't get that. So when this VM now starts to lose the battle, no ballooning driver means it says, oh, I can't do the polite way of claiming memory. I'm just going to start swapping to disk, okay? Which again can be very, very slow. Now, you can on the ESXi host dedicate a really fast SSD disk for swapping. Okay, that would help out swapping, but to me, you're still overcommitting your memory. So there's still a memory issue, but you're just putting your swapping on a faster disk as opposed to a spindle disk. Okay, so you want to make sure you got your VMware tools with the VM control installed, and then it will do ballooning first, and then after that, it will do swapping. Now, one thing I do want to mention here, and just to kind of correct myself, because I think let me just mention this one thing here. So great, ballooning can do 65%, and then the rest could get swapped out if we need to do that. Suppose if you gave your virtual machine a reservation in memory. Remember we talked about shares, limits, and reservations. That was part 2. If you haven't seen that, go watch that. So shares, limits, and reservations. Let's say you gave this guy a 200 meg reservation. So this is real memory. You're guaranteeing this VM access to that physical memory, okay? So now if this VM is the one losing the battle for memory, the VM kernel says, I can't touch this 200 because I promised it. It's a reservation. I can't touch it. It's allowed to have that. It's going to take the ballooning, the 650, and balloon. And then after that, it'll take whatever's left over. That's 200, that's 850, so that's what, 900, that's 150 megabytes. In case it needs to take that, it could drop that to that VM kernel swap file of that VM. Okay? Now, another thing I always like to point out at this stage, I mentioned this VM kernel swap file is equal to the amount of memory you gave your VM minus the reservation. So in this example, let's say this is 1,000 megs minus 200. This would be 800 megs in size. Okay, I know this is 1024 or whatever. Okay, what some people will do, and I've seen this many times, and don't do this. They'll go to turn on a VM, and then all of a sudden they get an error saying, "Oh, there's an error. I cannot create that swap file." In other words, there's not enough space on their data store to create that VM kernel swap file for the VM. So you know what they do? They go and they set the reservation equal to the amount of memory they gave that VM. Now there's no swap file, right? And the VM is allowed to turn on. Great. They pat themselves on the shoulder, they walk away, problem solved, right? Well, not necessarily, because if you go to vMotion that machine onto another host, or if there's an HA incident where the host dies and that VM's got to start up on another host, if it can't guarantee that gig of memory, the VM's not allowed to power on, okay? So watch out for that. Another thing too, and I usually like to point this out, suppose if you don't want your VM to be ballooning. I don't want my VM to be ballooning. I don't want my VM to be swapping. Again, you could say, all right, I'm going to give this VM full memory reservation. It will never balloon. It will never swap. Okay? But again, you better have that memory available. And I talked about shares, limits, and reservations in part 2, so you want to watch that. Reservations could come back to bite you in the butt. So don't go in there, I'm going to set all my VMs reservation. Don't do that. You're going to be asking for trouble down the line. I just wanted to show you what's kind of going on here. Now, before I jump into transparent page sharing, there's one step I kind of forgot about here. So before we dump it to the swap file, generally speaking, you have pages of memory. I'll say this now and I'll correct myself in a bit. Stick around. They're 4 kilobytes in size. So what it's going to do, it's going to say, actually, let me back up. Actually, they're 2 meg in size. By default, it's going to try to use very large memory pages, 2 megs in size. I can't remember when this feature came out. It might have been in version 5. Who cares? It's available today. It's called memory compression. All right. So instead of me taking this amount of, we still do ballooning first. Ballooning is done first. But before we hit that, we dump the contents of memory to our swap file. Let's see if we can compress the contents of memory. So we got 4K page size, 4K. If we can compress that to 50% or better, great. We're going to compress it. We just freed up physical memory. If it can't do 50% or better, it says, sorry, I dump it to the swap file. Okay. Now, I did mention we use large memory pages, 2 meg memory pages. It would need to collapse those down into 4K pages at a certain point. And I'll talk about that with this thing called memory state. Okay. So keep that in the back of your mind. Ballooning is the first line of defense. So this is the machine that's losing the battle for memory. This is the low one. We're going to kick in ballooning. So if ballooning is not enough, then we're actually going to swap. But before we swap, we're going to see if we can compress our memory 50% or better. If not, boom, we just dump it to the swap file without thinking. So ballooning, compression, swapping. Okay? So these are 3 things we got to watch for memory. Now, transparent page sharing, all this really is memory deduplication. This has been around for as long as I can remember. I think it was even available in ESX 1.5, if I remember correctly, but I'm pretty darn sure it was also in 2.0. But anyways, this has been around for a very long time. Let me explain this and kind of what changed about 10 years ago, right? So this is memory deduplication. So what will happen is here's 3 VMs. And let's say, just for argument's sake, let's say they're all running Windows. They're all running Windows in the same version. I don't care, right? And when you look, as far as the VM's concerned, it's got content it's got basically content and memory. This stuff gets mapped to a physical piece of memory on your host. So this is your ESXi host. Here's the representation of the pages of memory on that host. So it's going to say, okay, this information gets mapped there. This red one will get mapped over here, and so on and so forth. But what it does over time, it'll say, hey, you know what? Look at this. This page of memory, let me change my color here. It's going to say, hey, this page of memory and this page and this page and this page, they're the same hash value. So instead of me mapping it to 4 individual locations, I could actually just map it to 1. So this is 4K, 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 4K. That's 16K. This is only taking up 4K of real memory. So that's memory. That's transparent page sharing. It's memory deduplication, which is really good. Now, notice I said these are all Windows machines. They could have been all Linux machines. That's fine. But let's say this is a Windows machine. This was a Linux machine. Let's say this was a DOS machine or OS2. How about that? I got 3 different VMs with 3 different operating systems. Odds are my transparent page sharing is not going to be that good. So you might have heard people say, oh, keep the same VMs with the same operating system, keep them on the same host. Let's have all my Windows VMs on this host, my Linux VMs on this host. And the reason why people make that statement was because of transparent page sharing, which was really cool. Okay, this saved you time. Now, let's say you just powered on these 3 VMs right now. You just powered them all on. Let's say they're all running Windows, they're all running Linux, whatever. So you power them all on. If you look at your transparent page sharing, it's going to be very low. It's going to be very small, if anything. And then if you walk away for 10 minutes and you come back, you'll see it. It goes through and it checks, and then it starts to kick in. So you'll see your transparent page sharing increase over time. Now, if this VM here, let's say this VM in the middle needs to change the contents of its page, no problems. We'll make a copy of it, repoint that page to here, and then it can make a change to it. So this is cool technology. I really like this. Now, about 10 years ago, and I think this was when ESX6 had sort of just come out, there was a study done. Doesn't really matter. There was a study done. Somebody found that, anyways, we could change memory of a particular VM. It was a very different type of situation, or very specific situation. So in the real world, generally it probably wouldn't happen. So VMware at that point says, okay, there's a potential security vulnerability, right? We're going to disable this, all right? So let's see what VMware did, what the VMware solution is. So by the way, let's say you're running version 5, update, whatever, TPS is disabled. So now, before I mention this, transparent page sharing, notice this VM here has 2 pages of memory that have the same value. That's the red value, and it's only mapped to one physical location. We still do that. So that's basically internal VM sharing is still enabled. So there's a thing called salting. Here's a knowledge base article you can look up. Just go to Google, type in that knowledge base article. You'll get a link to go to VMware. Now, by default, transparent page sharing is enabled, but it's only enabled within a VM. So that means it's this situation right here. This VM can do TPS within itself. It cannot do it with other VMs. Okay? So it's still a good thing for saving memory, and it addresses the security issue. It says, okay, I'm doing memory deduplication within my VM, but I'm not doing that across VMs. If you want to, you can enable that. You can say, I want to enable it completely on all hosts, again, depending on the settings, right? Yes, among all VMs. Yeah. So like here, and then set these values, and it would do it across all VMs on that host. Maybe you have a host that you own all the VMs on, and you want to optimize your memory. You can enable that transparent page sharing. Or let's say you go, well, I want to share memory between certain VMs only. I'm a cloud provider, let's say, and I want my ABC company to share transparent page sharing between their VMs, and XYZ company to do TPS between their VMs, but not. You could do that. You could set this based on these are configuration settings in the VM. I'll probably do a separate video on this. I'm going to be honest with you. Most people probably don't touch this at all. They just install the stuff, and it's easier just for me to drop in more memory. But again, just be aware of that. That's what TPS is, page sharing, transparent page sharing. Today, it's page sharing between VMs is disabled, but within the same VM, it's enabled. Okay, so that's a good thing. Now, the last couple things I want to mention is this thing called should be mem free percentage. What that really means is how much memory free should a host have before it takes action to do things. Well, what do I mean? Well, when I start swapping and ballooning, at what point does that host consider it to be a problem? All right, so the first variable we have to look at is this mem free percentage, right? The mem free percentage is the amount of memory the VM kernel should keep free. So it expects to see this. Now, it's not just a fixed number, it's actually a percentage. So depending on the size of your host, the first 4 gig, it's going to take 6% of that, and it's going to keep that free. The next 8 gig, right? So 4 through to 12, that's 8 gig. It's going to take 4% of that. And then from that 12 through to 28, so that's the next 16 gig, it's going to take 2%. And then after that 128, it's going to take 1% of memory. So I got a little example here. Let's say I got a host that has 128 gigs of memory. So the first 4 gig is 6%, so that's about 245 megs. And then after that, the next 8 gig goes up to 12, so that'll be 8 times 4%, right? So that's 327. And then the next 12 gig to the 28, so that's the next 16 gig, takes 2%, and that works out to about 327 meg. And the remaining is at 1%, so that would be from 128 gigs to 100. So that would be my next 100 gigs. So I'm at 128. Sorry, I got 128 gigs of memory, and that's up to 28 here. So that'd be 128 minus 28, 100 gigs. So that'd be roughly about 1024 megs of memory. So add those up. So my host would say I need to keep free just a bit over a terabyte of memory. I need to keep, sorry, not terabyte. That should say megabytes. Oops, sorry, folks. I just realized that. I should say megabytes. So it should say I need to keep 1923 megabytes free of memory. Okay, oh, just a bit over a gig it needs to keep free. At that point, once I start hitting that number, it's going to do things. So what does it do? Now I'm going to show you what this means in my demo. So there's a thing called memory state. You got high, clear, soft, hard, and low. I think they introduced clear in 6.0 if I remember. Doesn't really matter, it's there today. So when we're in a high state, and I don't mean like high, I mean high. When the host considers I got plenty of memory, that means I got 300% of min free. So in my case here, min free is 1923. Let's just say it's 2 gig, just for argument's sake, 2 gig. So 300% of that would be 300. So that'd be 3 times 2 would be 6 gig. So if I've got 6 gig of free memory, everything's good, right? So this is my threshold. If I got more than that, I'm good. After that, it says I need to start breaking up the large pages. Remember I said your 2 meg pages, we use large pages because it's better performance, but we start seeing 300%. So we hit 6 gig of free memory on my example. It's going to say, you know what? I think we're going to run low on memory. We better start breaking these large pages and then wait for the next transparent paging to run. At clear state, if you see a clear state, and you can see all this stuff, by the way, one method is through ESX-Top, which I'll show you. Okay? Clear state, that means I got 100% of free memory. That means I only got 2 gigs of free in my example, okay? In my example I'm giving you. So at that point, we break the large pages. We start doing transparent page sharing to collapse, to start saving memory. And again, we only do TPS within the same VM unless you enabled it across VMs. Now, the soft limit, we got 64% of free min. So 64% in my example of 2 gig is whatever number. I'm going to do TPS and I'm going to kick in ballooning. So remember I said, when do we start kicking in ballooning? That's when I kick it in. Now, hard state is basically I got 32% of min free. So whatever 32% of my 2 gig is, that's when I'm going to start doing transparent page sharing, compression, and then swapping. Okay? And then low is 16 gig. I'm going to compress, swap, and then I'm going to start blocking memory. Okay? So these states, which I'll show you on ESX-Top, is important to know, am I going to potentially get into trouble? Okay? And we talked about the terms ballooning, swapping, compression. So we'll take a look at that in our demos. Now, what are some of the counters we should watch for? I'll show you these in my demo. These are the memory objects, right? And these are the counters. So mem control size, that's the VM mem control. That's the ballooning. If you're ballooning, you've overcommitted your memory. Okay? Swapping current. Am I currently swapping? Right? So if I'm swapping, odds are I'm probably ballooning as well. Odds are, if I didn't install my VMware tools, I'll see this at 0. Okay? But I'm swapping. Okay? So swapping's not good. So that means you've overcommitted your memory, potentially. I'll show you that. This counter here, I honestly, I don't really look at these swap reads and writes. This just says, am I reading from my swap file or am I doing writes to the swap file? To me, if I'm swapping, I've overcommitted memory, generally speaking. Cache used, if larger than 0, compressed memory, possible memory overcommitment, right? And then if zip, so if large has, so this cache used, again, I don't really look at that one too much, but it's saying there is compressed memory for this VM. So that's a good indication. Oh, there's compressed memory for that VM? I'm probably overcommitted on memory. Zip, if larger than 0, actively compressing memory. So that means this VM's currently compressing memory. So that's an indication of, well, hang on a second, I got lack of memory. Unzip. Well, unzip is basically an uncompressing memory. Okay? So these are values. If you look at, you're doing compression, that means you've probably done ballooning first and then you're on your way to do swapping. So ballooning would be happening first, then you would generally see the compression, and then you're on your way to do swapping. So that means that this VM is suffering, and it quite possibly because you overcommitted memory. And I'll show you a couple of things on this in the demo, so you got to stick around. The last one I want to mention here is this NL value. Okay. In my CPU video, if you haven't watched that, that was, well, part 3. I talked about NUMA, non-uniform memory architecture. You want to watch that. This counter is important. So if you got a NUMA server, which you probably do, okay, it says if it's less than 80, the VMs experience poor NUMA locality. So what that's saying is if you're looking at a VM and you see this counter is less than 80, that means it's accessing its, if it's less than 80, that means it's accessing memory that's on a different NUMA node that it's on. So for example, in my CPU video, I talked about I'm going to create a VM that has more memory than one NUMA node. So now it's running across both NUMA nodes. So if that's the case, that could be impacting your performance of this VM. I'm going to probably do a separate video on NUMA because there's a lot to talk about there. But again, watch out for this. A good example of this might be, again, you gave your VM too much memory, or the VM is, a lot of its processes is running in a different NUMA node than it belongs into, okay? So that might be a memory issue. But these are the big ones to watch out for: ballooning, swapping, and compressing. Guess what? Demo time, so stick around. And by the way, hey, if you haven't hit that subscribe button, hit that subscribe button. And if you're stuck around this long, hit that thumbs up as well if you don't mind. I'll be right back in a second. Thanks. Okay, everybody, let's jump into the demo. So you'll see right here in my vSphere environment, I've got it's a vSAN cluster, but that doesn't really matter. I got my host 01, and I got all my VMs on my host 01, so I can stress it. I just want to show you a couple of things here. Notice my app VM. When I click on the app VM, showing you it's got a gig of memory, so it's under the VM hardware, and it's located on my vSAN data store. That's underneath the related objects over here on the right. So it's got a gig of memory, and the VM is currently turned on. Let's look at the vSAN data store. Let's go to vSAN, let's go to files, and let's go to, that was app, right? Let's go to app, and then over here, you'll actually see the swap file. It's really small, okay? That VM has a gig of memory. Now, isn't the swap file is typically equal to the amount of memory give the VM minus the reservation. So I've got a gig of memory in that VM. Why isn't the swap file 1 gig? There's no reservation, by the way, just to let you know, there's no reservation on that VM. With vSAN data stores, the swap files by default are thin provisioned because it's an object now. Okay, it's an object in the vSAN data store. If you're not familiar with vSAN, watch my videos. So that's kind of cool, all right? So it does save space because imagine if you had a bunch of VMs, they all got like 32 gigs of memory, 48 gigs of memory, whatever. When you turn them on, it's going to create a swap file, 32 gigs, you're going to consume a lot of space really fast, right? So that's kind of neat, okay? So it's thin provision. Now, if it starts to need it, it's going to start increasing, okay, in size. So anyways, let's leave that alone for now. Let's go back into here. Let's look at Web 2. Web 2, if I look at related objects over on the right, you'll see it's not on a vSAN data store. It's on my ESXi01 local. So let's go to that disk. By the way, sorry. Notice the VM here is turned off, and the VM has been allocated a gig of memory. Okay? Let's go to that disk. Sorry, that was Web 2, right? Go to Files. Let's go to Web 2, and you'll see there's no swap file here. Okay? The VM's turned off. Swap files are created when you turn on the VM, deleted when you turn it off. Let's go back to here. Let's turn on the VM, power it on, and we give it a few seconds to come up. All right? This will take a few seconds here. Let's go back to, let's let it finish booting there, I guess. Okay, whatever. Let's go back to ESXi01 local. Let me refresh. Let's go back to Web 2. And we see right here is the swap file. And you see it's a gig in size. So I just wanted to point that out. vSAN's a little different when the size. Okay, folks? All right. Now, let's do something else here. So I got 3 VMs powered on host 1. Let's go in and get PuTTY going here. Let's host 1. And I'm going to log in root. And let me obviously change my appearance and stuff because you guys know I like to do that, right? Let's change settings, appearance, change the font size to 14. Okay, let's do the colors, the background color. And let's pick this one, looks good. We'll say okay, apply. All right, let's go full screen. I'm going to run ESX top. And if you don't know what this is, watch my first part 1, okay? So right now it's looking at CPU stuff. We're not talking about CPU, we're talking about memory. So I'm gonna hit M for memory, okay? Now you can see the VMs here at the top, and you see a bunch of other processes that are consuming memory, right? Let's just look at the top here. Again, you see the date, the time, or so the uptime. You see the number of worlds, the number of VMs. You'll see the number of virtual CPUs in this environment. Okay, great. Now, memory over commitment average. This is just like CPU. Notice they're all like 0, 0, 0, and 0.1 or 0.01. The first one is the average for the last minute. This next one is the average for the last 5 minutes. And the last one is the average for the last 15 minutes. If you see whole numbers here, like 1 point something, that means you're consuming all your memory. That's not a good thing, okay? You see PMEM in megabytes. There's 32,762 total. That's the physical memory in the host. You see 334 megabytes is managed by VMkernel. You see about 11 gigabytes and change is managed by others. There's other drivers and stuff, right? And then you see you got about 20 gigs free. Then we see VMkMem 32601 managed. That means the VMkernel is managing about 32 gigs of memory. 940 is the min-free. Remember I talked about min-free? So it depends on how much memory you have in your server. It's going to say, I need this much memory. I want to see this much memory free before I start doing things, right? We talked about that in the lecture. So again, I got 32 gigs of memory in that server. So works it out to about just under a gig for min-free. We see we've got about 16 gig reserved for various processes. We've got about 16 gigs unreserved. And then we're in the high state. Remember the different states I talked about, right? So we're in the high state. I'm going to hit S here to update, to do this thing update every 30 seconds because I don't want it constantly clicking all the time. So S is to update speed, right? Now, pshare. This is your transparent page sharing. Notice I got about 55 shared. 53 of them, 55 megs is shared. 53 is common. 53 megabytes is common among worlds. And 2 megs in saving, okay? Remember, I talked about transparent page sharing. By default, intra-VM page sharing is disabled. Page sharing within a VM is okay. So you could enable it and say, I want to do page sharing between all my VMs. So this comment is, this is how many megabytes common among other processes that it can be shared, but we're only doing 2 megs. Notice the savings plus the common equals the shared. So 53 plus 2 equals 55. Okay. Now these are the, so I look at that counter. These are the ones I actually really look at now, okay? That's like where my eye will go first, generally if I suspect there's a problem. Swapping. Currently I'm doing no swapping. That's good. Let me talk about the next one out in a second. This would be, if I was swapping, this would be number of reads per second and the number of writes per second swapping. Again, I don't really look at that often, to be honest with you. If I'm swapping, I'm swapping. Reclaimed. How much, right now, I'm not doing any swapping or ballooning or anything like that. This is how much memory VMkernel can reclaim with ballooning, swapping, and so on. Zip is compression. Right now, I'm not doing any compression. Nothing's zipped up. And, well, I'm not doing any compression, so I won't see any savings, right? Okay. Remember, we do ballooning, compression, and then swapping, right? And the next one here is mem control. That's the ballooning driver, right? Currently, I'm not doing any ballooning. The target, let me come back to target. 1256 max. Remember I said that the ballooning driver can typically claim 65% of the VM's memory. So if you give a VM a gig of memory, it should be able to claim roughly, let's say, about 650 megs, right? That's if, now that depends on your operating system too. Some operating systems have, I think they're called pinned pages or locked memory, right? It can't claim those, so it may be less than 65. So of all my VMs here, right? Of all my VMs that are running, let me hit Shift V just to show us the VMs. Of all my VMs here, it says ballooning can claim this amount. So remember, ballooning's the polite way. So if we're over subscribing our memory, Ballooning is the polite way of saying, hey, VM, the one that's losing a battle, sorry, I need to give that physical memory to somebody else with a higher priority. That's the polite way. Swapping is the rude way. That's bad. So, again, I'm doing nothing here, right? Okay. Might have wondered why I stopped the recording. I actually did this before, and my machine crashed on me. So a lot of times it's good to do your recordings in small chunks so you don't have to do everything all over again if you get a crash, right? I should have known better, and I should have rebooted my machine before I started doing this. All right, so now we're looking at the different columns here. You see, okay, it shows me right now, here's my Web 2. You'll see, again, the mem size. It's got about a gig. That's kind of like, I look at mem size as this how much memory you gave the VM, and that's going to kind of include the overhead as well, okay? Granted, this is how much, okay, I've given the VM a gig of memory, but does it actually really need it? A lot of times when your operating system starts up, what it does, all of a sudden, it trips like any memory type performance monitors, right? The reason why is your operating system a lot of times goes out and touches all the memory just to make sure it's all there, okay? So this is kind of like it says, okay, we're granting it about 200 megs, right? Now, out of that, it's consuming about 175, okay? And the size target means this is what VMkernel wants to give it physically, right? So that's okay. So that's not a problem. TCHD touched, I think that is, oh shoot, I forget that one. That is, oh, it'll come to me. I'll mention it again. I don't go through all these. You'll see I got swap current, swap target. We'll show you some of these as I go through here. What I do want to show you is overhead. Currently, this web VM has a 32 meg overhead, let's say, and overhead max is about 36. Remember I talked about overhead. Nothing's free. When you create a VM, it costs you in memory. So it says, oh, you got this many processors, that much memory, this disk, that disk, whatever. It's going to cost memory, and that's what the overhead is. All right? Now, let's do something here. Let's go to Web 2. Let me show you something on Web 2. Let me go to Web 2. Let me right-click on Web 2. Let's go Edit Settings. Web 2 ain't going to like this. Let's go to memory. Let's go to limit. Right now, there's no limit. There's no reservation, nothing. I'm going to give it a 1 meg limit. And I'm going to say, okay, what did I just do to Web 2? I said, oh, yeah, here, Web 2, you got how much memory? It's got a gig of memory. I said, okay, Web 2, I'm giving you a gig of memory. But guess what? You can only use 1 meg of physical memory. So guess what it's going to be doing? We should see ballooning compression and swapping going on. So let's see what happens now. Let me update my seconds. So Web 2, I may have to give it a few seconds here. Okay, I just had to wait maybe about a minute or so. Again, I'm in a lab environment, right? It's a nested environment, so in a real world, it would be a lot snappier on the response. Notice Web 2 now. Notice over here, first of all, I see we've got transparent page sharing is up again. Oh yeah, remember transparent page sharing is one of those things that increases over time. So I just started up some of these things, right? Remember my demo, I just started up Web 2, so it does take a little bit of time. Anyways, enough of that. Let's look at swapping. I'm currently swapping 139. Okay, and this is how much it can reclaim back. I'm doing a lot of writes. Again, I don't really look at that. I look at I'm swapping. Okay, memory compression. You see, I'm doing some compression. Remember, first of all, we do ballooning. Notice again, I'm ballooning here. Current. Notice again, current is 587. Target's 587. So it looks like I maxed out the ballooning for that machine. So guess what it does? So it's ballooning, compression, which it's done. It's doing or done. And then it goes into swapping, right? I might see compression go up a bit. Depending on your environment, you may see that go up and the swap go down a bit. But anyways, right now, if I just walked into your environment and I saw this, I'd say, oh, what's going on? So see how by me modifying a setting in the VM, I can create swapping and ballooning, right? Now, where do I see over here? I see currently I'm swapping. You see the swap target. Again, I don't really look at that too much, all right? It says, okay, it's probably going to get worse. That's what it's kind of telling me. But I look at I'm currently swapping to see the reads and writes, whatever. I don't care too much about that. What about ballooning? We have to activate the field on that. Let me hit F for fields. And then notice over on the right here, You see J is for mem control. I'm going to hit J to activate that field or that column, and I'm going to hit enter. And then now, all of a sudden, I see Web 2 mem control size. So this guy is ballooning, right? Looks like I pretty much maxed out my ballooning, like I said. And I'm swapping. So this VM here is suffering. I can tell you it's hurting really bad because I only give a 1 meg limit. Now, what's this mem control question mark? This is interesting. It shows me why. That means the ballooning driver's installed. Okay? All right. So that's kind of cool. So swapping's a bad thing. Ballooning's a bad thing. Let me show you something else here. Okay? Let me go into my VM. I'm going to power on. I got a VM here that I created. I didn't install an operating system. What I did is I said, I want you to boot from an ISO, a CD. Let me actually right-click on this. Edit settings. And you'll see it's actually booting from a content library that I have. I actually downloaded a tool called MemTest. Some of you may already be familiar with it. It's a really good tool if you want to do burn-in on your like you got a physical machine. Don't run it in production. If you got a physical box that you need to burn in the memory to do testing, you could boot it with the USB and then have it burn in. I actually just recently had to do that on one of my machines. I thought I had a memory problem, but anyways, doesn't really matter. So I just said I'm going to create this VM and have it boot from CD, okay? And then it's going to stress the memory. So let me just power that on. Let me power on this guy. Let's power on a few of them. Okay, I'm going to power on 3 of them. I've given these VMs here about 10 gigs of memory each, these MemTest ones. Okay, so I'm going to let those power up, and then we're going to come back and take a look at it. So it's actually booting up. Let's launch the web console. So there we go. That's what it boots up, and it should start in about 6 seconds or so. We'll give it we'll give it about a minute for things to settle down, and then we'll come back. Okay. Okay, so I just gave it maybe about 30 seconds or so. You actually see there's a few things going on here, right? I'm in a soft state right now. Okay, remember we talked about the different states. So I'm in a soft state. It just went to clear state here, right? I got about a gig free. Actually, when I powered those on, it was a lot less because it touched everything. But you'll notice now, again, my swappings increased. So this is not good over here. I only got a gig free here on my host, and I got a total of 32 gigs, right? So things are getting bad here. You see my compression has gone up quite a bit. It's doing a lot of, which is good. Mem control, again, is cranked up as well. So we're doing a lot of ballooning as well, and then we're doing a lot of swapping as well. You'll see over here, swapping current. Again, these VMs here are currently swapping. Yeah, you can see that number just popped up all of a sudden, right? So I got to let this settle down. But anyways, I'll just leave it, right? What I want to show you, again, you see swap current and all that stuff, right? So what I want to show you is, now, remember I said we do ballooning, compression, swapping? Look at this over here, 0 for ballooning, 0 for ballooning, 0 for ballooning. Why? Why is it not ballooning on those 3 VMs? Notice under here, mem control question mark, N for no. What does that mean? That means those 3 VMs do not have VMware tools installed, or remember the VM mem control process? Something's happened to it, right? I remember back in the old days, people would go and say, oh, this VM is running poorly. They would say, they would go into their operating system of the VM. Let's say it was Windows. They'd run Task Manager, and they'd say, oh, what's this process? VM mem controller, and it's consuming a lot of memory. I'm going to kill it. And they would kill the process, right? I don't think you can do that today, but again, you never know, right? Some things could be possible, right? They would kill that process. And then what did that do? It basically says, oh, I can't do the polite way of ballooning anymore. Guess what? I'm just going to be doing VMkernel swapping now. So when they did that, their performance got even worse, right? So anyways, this no here indicates there's no VMware tools, or maybe somebody killed that process, right? Now, in my lab environment here, remember I said I booted up with the CD? Well, there's no VMware tools, right? So this is why. So these are things that you should look for when we're talking about memory. So again, when I just quickly look at stuff, I'll see, are we swapping? Yeah, we're currently swapping. Are we ballooning? Yes, we're currently ballooning. That means we're probably overcommitted on memory. Look at this. We got a total of, VMkernel basically has 32 gigs over here. and we got about, we're in a clear state, and we only got about a gig and some odd free. So we're basically, that's not good. In a clear state, again, it's not the worst, but it's not the greatest either, right? So you don't want to be ballooning and swapping, so to speak, okay? Also watch out, again, if you got 1 or 2 VMs ballooning or swapping, again, maybe somebody put a limit on those VMs. So just a few things to watch out for. Is there any other columns here? Those are the top ones, I'll be honest with you, that I look for, right? Again, there's a lot of, there's one for compression queue. Let's look at that. Anyways, there's a lot more counters if you really need to dig in a little deeper. So that's kind of nice. The touch chair, I think that's your, I always forget that one. Let me look that up. 1 second. Sorry about that one, folks. I obviously don't look at that one that often. This is your working set of the VM, the TCHD. I look at that as touch. That's the working set of the VM. How much is it actively using memory? You see the ones that are running mem test down here, they're actively using a lot of memory, right? And you see the numbers are kind of changing and stuff like that, okay? So that's it. I hope you found this beneficial. If you haven't subscribed to the channel, please subscribe to the channel. If you found this in the slightest bit entertaining, hit that thumbs up if you don't mind, and share the video with your colleagues and stuff. So thanks again. Leave comments below. The next one will be on storage. This will be the next part of our performance series. So leave comments and questions below. See you in the next one. Bye now.